Now, the problem here is that the position of the unknown is not the same in the two logarithmic expressions. To solve this problem, we need to apply a law in logarithm that will enable us to swap the positions of the base and the argument. That law is simply like this. So if I have log to base a of b, it is equal to 1 over log to base b of a. Now, so 1 over log to base 8 of n will now be, if I apply this law, log to base n of 8 plus 1 over log to base n of 1 over 4. I will now see that the bases are the same. It's equal to minus 5 over 2. Also, we need to see simplify. Since we've made the bases the same, let us simplify. Log to base n of 8 can be written as log to base n of 2 raised to power 3. Now plus 1 over log to base n of 4. 1 over 4 can be written as 2 to power minus 2 equals to minus 5 over 2. We will now apply another law in logarithm, which is the power law. If, for example, I have log to base a of x raised to power p, it is the same thing as p log to base a of x. So this number here, 3, will come down, and this number here, minus 2, will also come down. That becomes 3 log to base n of 2 plus 1 over, here becomes minus 2 log to base n of 2 is equal to minus 5 over 2. Now, this plus will multiply this minus to give minus. So 3 log to base n of 2 minus 1 over 2 log to base n of 2 is equal to minus 5 over 2. Now, let us make one crucial substitution. We will assume that log to base n of 2 is equal to x. Then put in x where we see log to base n of 2. Here is 3x minus 1 over 2x is equal to minus 5 over 2. If I multiply through by the denominator here, which is 2x, I will have a quadratic equation. So 2x times 3x will give me 6x squared minus 2x times 2x will give me 1. 2x divided by 2x will give me 1 is equal to minus 5 over 2 times 2x. So this will cancel this, remaining minus 5x. It becomes 6x squared. Minus 5x here becomes plus 5x minus 1 is equal to 0, a quadratic equation. Now, to solve this equation, we will use the factorization method. So 6x squared plus 6x minus x will give us 5x minus 1 is equal to 0. We will now group. In the first bracket, 6x is common, remaining x plus 1. In the second one, minus 1 is common, remaining x plus 1 equals to 0. These two are the same. I will take 1 and put this other one in a bracket. Now equate them to 0. X equals to minus 1 or x equals to 1 over 6. Let us remember that we made log to base n of 2 equals to x. So we will now back substitute in both cases. In the first case, when x is minus 1, that becomes log to base n of 2 is minus 1. And then n minus 1 or n to power minus 1 will now be 2. So n to power minus 1 is 1 over n equals to 2. So n equals to 1 over 2 in the first case. In the second case, log to base n of 2 is 1 over 6. That becomes n to power 1 over 6 is equal to 2. And then n equals to 2 to power 6. 2 to power 6 is equal to 64. If we now back substitute the values of n, which are 1 over 2 and 64, into the original equation, we'll have minus 5 over 2. I would like you to do that and then leave your comments in the comment section. Also, I would like it if you like this video, subscribe to my channel, and share this video. Sharing is an act of love, and love doesn't cost a thing. See you in the next video.